Thank you for joining me for my talk today, and thank you to the organizing committee of Clojure for giving me this opportunity to stand on a soapbox. My name is Paul S. Chun, and some of you might recognize me as the organizer of Clojure Tokyo, the meetup group. You can find me on Mastodon at psc@mastodon.social and in the Clojurian Slack at Paul S. Chun. My talk is called A Clojure Carol, 3 Clojure Web Development Aha Moments. I plan to discuss 3 different things I've learned the hard way while building different web applications in Clojure over the last few years. Not so coincidentally, these are also common discussion points from the Clojure Tokyo meetup. One of the earliest members of Clojure Tokyo was a fellow Tokyo expat from an English-speaking country and a brilliant JavaScript developer. He's very talented and knowledgeable, much more so than me, and it was clear he'd read plenty of literature and content on Clojure. Still, the one thing he said he'd been wanting to do with Clojure, build a simple CRUD application, is something that I believe he never got around to doing. And I can't blame him. While it's straightforward enough to follow a library's documentation to achieve a specific outcome, incorporating your opinion while keeping an entire project maintainable and something you're proud of can be intimidating. I believe it's a core desire for humans to not just want to create something, but something we're proud of. Something we're not embarrassed about having our name attached to. So, this talk is for him and anyone else wanting to build a Clojure application that might find themselves tripped up by the finer details. That said, I hope experienced Clojurians can also take something useful away from this talk, even if it serves as nothing but a refresher. For each of my 3 points today, I'll start with my first exposure to the topic, which I'll call How It Started. Then I'll talk about my initial aha moment, which I'll call Wait What? Then I'll talk about how that aha moment stewed into goodness over time, which I'll call That's Wonderful. As an example project domain, I'll be taking elements from a writing app I've written. This is a service that's up and running and endorsed by universities and other organizations, so this isn't just fluff I'm feeding you, I promise. Okay, so now we're past all the expectation setting. Let's go ahead and jump right into the first point. REPL, the ghost of programmer past. I call this the ghost of programmer past because when you come to Clojure from a different language, you come with existing habits and expectations. This topic's been discussed plenty of times in the Clojure community, so I won't dwell on it for too long. Still, I think it's important to include this in case it's new territory for anyone watching. So, how it started. I'm going to do my best to put you into the shoes of early Clojure Paul. What habits did new Paul have when he came into the Clojure world? I had attended my first Clojure meetup, and afterward was curious about this REPL acronym I'd heard so much about. I looked it up on Google, and a snippet from the official Clojure website appears telling me a Clojure REPL, standing for Read Eval Print Loop, is a programming environment which enables the programmer to interact with a running Clojure program and modify it by evaluating one code expression at a time. Well, I did that in Rails with Rails console and in Django with Python manage.py shell, so I'll do the same thing in my Lineagen project by using line REPL. Nothing new. I can either type directly into it, or I can copy and paste functions from my text editor so I can check output for different inputs. Neat. Wait, what? As I build this application, I'm also reading Daniel Hickenbottom's Clojure for the Brave and True, which touches on the REPL in the Emacs section. Great, so now I know how to start evaluating S expressions from within my text editor. No more copy and paste needed. However, I'm not really sure how to make use of this new skill. I didn't feel very confident in my Clojure abilities, so I'm still reliant on documentation of the libraries I'm using, and hoping that I'm able to figure out how to stitch things together. So I guess that's what the REPL can help me with. Eventually, I run into a wonderful video called REPL Driven Development, Clojure Superpower by Sean Corfield. In this video, Sean uses a REPL inside of his text editor to mercilessly turn a blank namespace into a functioning web app. A big part of the technique in this video is evaluating stray expressions through his editor written in his namespace that for someone coming from Rails or Django just felt like unapologetic polluting of the code base. One expression literally just gave the result of a function call to an HTML templating system. Isn't Clojure supposed to be about writing a bunch of pure functions? Like, what's going on here? A random evaluation in the namespace? But it became clear to me why he did this, to make sure it worked as expected right away. And once it was clear that it did, it got working code out really fast. And this code that looked like it was polluting the namespace a second ago just got tested and now is producing expected output. Aha! So the REPL isn't just something you type into in your terminal. It's also accessible in text editors for use as a learning and understanding aid that will instantly and conveniently evaluate code, whether it's a function you just wrote, an external library, or Clojure core. Once I understood the value in this technique, I did my best to copy it. That's wonderful. Using a REPL in my text editor, it improved my code in many practical ways. For starters, development speed went up big time. I wrote up a big, gross, unreadable functions, changing assumptions on the fly in an exploratory manner, and tested them whenever I felt a need to with a one-liner in the same namespace. No separate files, no formal conventions, just you, the code that you wrote, evidence that it works, and the confidence that comes with knowing that it does. It also became much easier to start splitting these giant functions up into many smaller ones, which made code more readable and functions more reusable. Additionally, and perhaps more importantly, it gave me a lot more confidence in my Clojure ability in general. I've never encountered a tighter feedback loop than the REPL in my editor. This means that anytime I really wanted to wrap my head around certain functions, I could do it right away and just as quickly understand the behavior. Now, I promised I wouldn't dwell on this topic for too long, so the last bit of information I'll include is that there is a lot of REPL support for many different text editors, and to check out Sean Corfield's REPL-driven development on YouTube. So moving on to the next ghost now. All right. Models. The ghost of programmer present. I call this the ghost of programmer present because your domain models are destined to become outdated as your knowledge of your domain improves over time. All right, so how it started. Let me put you back into the shoes of early Clojure, Paul. When planning the concept of this app, I knew some nouns had to be a part of it. Users, text posts, sessions. So these are obvious necessities. And in an object-oriented language, we'd most likely represent these nouns as classes. But what about in Clojure? After surfing through Clojure community sites, I found my answer many times over. Just use maps. So now, because I decided to use Postgres for persistence for this app, I started how I would in a Rails or Django app. I figured out what tables or models need to be there, what their attributes are, and how these tables should relate to each other, all before anything else. So easy enough. But then I was greeted with a pickle that would have been trivial to deal with in a Rails or Django app. How do I manage the data corresponding to these tables from within my app? Going with the just use maps methodology, I used maps. In fact, I wrote many of them in line across many different functions. This just led to frustration. Now I have multiple different definitions of what it means to be a user or a text post. So I can do my best to unify these maps across functions and make them all consistent with each other and what's in the database. And while I know this gets the job done, it also feels wrong because once the database changes once, I'll have to change my code base in many places. Not just that though. Another big source of pain that I encounter while living like this. When I'm passing one of these objects into a function, how will that function know what attributes to expect? It feels totally improvised, like that user is not the same as that user. Amid my frustration with this flimsiness, I read Alex Miller's take in his book, Programming Clojure. He mentions constructor functions as a means to decide on a noun structure and create instances of it with data. It's somewhat of a revelation, but it still feels flimsy. Is a function that basically returns the same map that was passed in as an argument actually useful? How is this not just a glorified identity function? And this approach doesn't address a major concern of mine, which is how can I be confident that it always returns a valid user map or text post? To answer the last part, I turned to schema libraries. I used Clojure spec, but could very well have used schema or Mali. And just like that, my constructor function was spitting out schema validated maps. Not too bad, right? Then over time, reality's hand left its mark on my face. Surprise, I didn't get it right the first time. So to adapt my code base, I'll have to adapt my project first in my database and then in my code. So this feels tedious and tiring. This can't be right, can it? Wait, what? So being really loose with my nouns wasn't good enough. Being strict with my nouns was also not good enough. So what gives? Is there possibly a middle ground? I want to credit Sudsy, a member of Clojure Tokyo, for pointing out a very accessible answer to this question under my nose that I completely ignored. The request map from Ring. So this is a very common component of many Clojure web applications, so maybe you'll know the answer to these questions. So question 1, is there a strict schema written for Ring requests? No, because it'd be impossible to extend. Do you have an idea of what's in such a map? Yes, because you already know what kind of data an HTTP request has. For example, it has request method and URI. And depending on which middleware you extend it with, it'll have, for example, session data. Aha! So the sweet spot is, in fact, that plain old function I rejected earlier, structured enough to communicate base attributes and intent, but not dogmatic about structure, so adding additional keys is just fine. So I went with a less strict constructor function, and it worked out great for me. Looks like Alex Miller knows what he's talking about. I learned to finally accept that there's nothing wrong with a plain, unheralded function, and proceeded with unchecked constructor functions. That's wonderful. So I expected my issue with domain models to be a code issue. It ended up being an issue with my relationship with code. By dropping my unnecessary desire for certainty, I've accepted plain functions as an excellent means to both stay consistent across my application and to know what attributes a noun should have through its defined structure. As users keep telling me what changes they'd like to see, I can count on my database tables to reject bad data, but everything between what a user inputs and the database layer gets to stay extremely malleable. That gives me peace of mind that my code lies in the sweet spot between flexibility needed for quick development and modification, and consistency and communicativity needed to know what's going on at a moment's notice. But is feeling good about domain models enough to make me confident in my project? Let me take you to the third and final ghost. Shearing layers, the ghost of programmer future. I call this the ghost of programmer future because the theory behind shearing layers is meant to help you build abstractions which are made so future you doesn't hate current you for turning your code base into spaghetti. How it started. So this will be our last teleportation today to early Clojure Paul. This time, early Clojure Paul is equipped with his trusty REPL and also has an opinion as to how to model his domain. Now, here's my handler logic in an early stage. As I develop my handlers, I decided to just directly use the wonderful HoneySQL library within them. Now, is this bad? In this situation, I have two handlers, so in my opinion, it's not such a big deal. Like, I'm not phased. Now, each of these handlers has a few different responsibilities. They take relevant data from the request, they interact with the database or mailer or whatever other parts of my tech stack, and they return a response. So sure, these handlers have a lot going on in them, but there's only two, so I'm not going to sweat it, right? Not a big deal. Okay, so now pretend that I have not two, but 20 of these. After writing the 7th or so, I'm pretty sure that my stomach's just going to turn at the idea of continuing to call HoneySQL directly inside of these handlers because there's just so much repeated logic. So as seems to be normal in other projects, I made a DB namespace and threw all the database-related logic in there. In essence, pardon me. In essence, I took an S expression from inside of a handler and turned it into its own function, complete with a name that indicates intent. Now when I look at the handlers, it's much easier on the eyes, which feels great. And all my database logic is now tucked away in the DB namespace, which in theory should be good. Unfortunately, my new DB namespace is actually gross. It contains a lot of repeated logic, and it's not immediately clear how to tidy it up. I know I should follow basic principles of DRY or don't repeat yourself, but how and where to stop repeating myself, that's not obvious at all to me at this point. Wait, what? I then stumbled upon a wonderful paper called Big Ball of Mud, written by Brian Foote and Joseph Yoder, and it provided a lot of insight on how to not make your project a, well, big ball of mud. There's a part of the paper that really targeted my issue, the concept they've taken from buildings and applied to software development called shearing layers. So if, like me, you've never built a building, then thankfully they elaborate on what they mean. Here's how it applies to buildings. So the big statement is that a building isn't really one thing. It's a group of layers of different longevity. For example, the piece of land that the building is built on is a layer and it will pretty much never change. And the structure that's built on that land will change every 30 to 300 years. That structure will have a skin that changes with the taste and fashions of the time every 20 years or so, and services change more quickly than that. For example, my apartment has Cat 5 jacks in it, and it already feels dated in this Wi-Fi age. But anyway, the claim is that for buildings, it comes down to one principle. Different artifacts change at different rates, and that's how they should be grouped. So I take this approach and take a look at my code in this database namespace from a high level. On first glance, there are two obvious layers, one layer for communicating with the database itself and one layer for defining queries. With my trusty REPL in hand, I make a few attempts to separate the logic in this way, and I wasn't happy with the attempt, but that's fine. It quickly turned into a second attempt, which I ended up liking enough to keep. Aha! To abstract away redundancy, split logic by how frequently you expect it to change, and continue splitting until you're happy with the results. So, with the database as my first source of success with this technique, I applied it elsewhere, both on this project and in others. And sure enough, they all yielded code that I returned to months later and still understood. That's wonderful. Some can argue that shearing layers isn't perfect, but if it yields acceptably clean results and is easy to understand, that's a huge victory in my books. But something else very important is going on here. When I was still working on Rails and Django apps, I was expected to follow convention. For so many problems, Rails or Django provided an abstracted solution already, to the point that abstracting never became a habit for me. Aside from a very small number of abstractions for niche portions of business logic, I'd never written any abstractions in Rails or Django. And for the few I did write, it felt uncomfortable because it was unclear where in the codebase they belonged, or how I should communicate what the abstractions are and why they're there. Applying shearing layers to my Clojure project gave me a lot more confidence to build abstractions, perhaps to the point that asserting my opinions in the form of an entire framework isn't daunting anymore, whether in Clojure or in other languages. This is a step I'd never have gotten to if I continued operating in a worldview that I was forced to adopt, as is the world of convention over configuration, rather than trying to forge my own worldview, and that's been extremely rewarding for me. So to end this final point of mine, I'd really recommend giving the Big Ball of Mud paper a read. So that concludes the three main points of my talk. To reiterate, I've talked about the REPL, and to not type into it and instead use it frequently and fearlessly in your editor as you develop. I've also discussed handling nouns in your project, and how writing flexible constructor functions is adequate, and that dogmatically checking its schemas will slow you down. And lastly, I also covered the shearing layers approach to splitting code based on how frequently it changes, and how doing so will help your project's code base remain intelligible and something you're proud of. I think again about the member of Clojure Tokyo that wanted to build a CRUD app, and hope that if he takes in these 3 strategies, he can build with confidence, and I hope that anyone else watching is able to as well. Thank you, and I'm happy to start taking questions now.